All right, class, welcome to section 2.3, graphs for quantitative data. So basically in this section, we're going to start talking about histograms. One of the things to note here is that histograms, a rule of thumb here is to use histograms when data consists of 100 values or more. We won't be able to do that because it's not realistic for practice purpose here, but once we get more of the ball rolling towards the middle end of the semester, we'll be using web-based technology to make histograms. So for all purposes right now, we just need to learn how to do it, and with an overabundance of numbers, just doesn't make realistic to do. But that's one of the things to keep in mind, that if we don't have sufficient data set, basically what that means is that you won't get a very good, accurate you could get a histogram, but it's not going to be as accurate in its representation, so why bother doing it? So but nonetheless here, one of the things to point out that for histograms that the bars need to be adjoining. So histogram consists of adjoining bars, and also here it has both of a horizontal and vertical axis. The horizontal axis is the representation of the continuous data. So you want to make histograms particularly for quantitative data, or more specifically for continuous data. However, it can go either direction here. So I'll state that here in the notes, that keep in mind here, quantitative data can be either twofold, two things. So we can have discrete, or we can have continuous. And this will outline what I mean by grouped and ungrouped data. So for the most part, not all the time, but for the most part, discrete goes with ungrouped data, and continuous goes along with grouped data. So again, I should iterate, that's not always the case, but just a general rule to keep in mind when we start looking at grouped data and ungrouped data. As I go through this, for instance here, the different types of quantitative measurement. So again, I want to outline that the horizontal axis is going to be that the units of that quantitative data. So inches, centimeters, pounds, time, etc., that sort of thing. And the vertical axis goes back to frequency or relative frequency. Or there are other things here too, or cumulative frequency. But we won't do that for a histogram. For cumulative frequency, basically gets tied or attached to a ogive. So, and we won't cover that. It's a little extent of the curriculum. I had you make or figure out what cumulative was, and it's an understanding that needs to happen. But as far as a graph represented for that, those are called ogives, and we won't. I'll just probably talk about it, but it's a little more at the top for this is just introductory class, so that is yet to come. Other things down here is also, yeah, I love this here. Give you the shape of the distribution. That's important here. So it's important to know what that is, and also the center and the spread of data. All those things can entail there from the histogram. So it's a lot better than looking at number sets, data sets, but turn it into a picture. This is a very effective picture, telling a lot more of a story than what the data displays. So down here we have some acronyms to follow as I'm going to start using it. F stands for frequency. That'll be short, and a lot of shorthand notations as we get there more into the next section. 2.4, 2.5, we'll start talking more about symbols and notation, because it's a lot easier to use a symbol than to write out the whole definition. For example, F for frequency, or RF for relative frequency. N there is pretty universal. Anytime you see N, that's going to stand for the sample size. And it is also the total number of the values. When I ask you to sum the frequencies all together, that is a sample size, that is also n. You'll see the letter N in any research article. It's universal. All around the world, it stands for the sample size. So coming down here for construction for a histogram, there's basic components here, and this first one outlines what's called a class boundaries. You could tell here for this there's a lot that entails the discussion of class boundaries, and it's rather complex there. I'll talk about that. I have my way of doing it, but certainly I leave it here for the notes for you to reference. Once the class boundaries are created, number 2 here is the figuring out what the y-axis is. And yes, scaling is important, so you want to have a nice even scale. And then the last part on there, draw the bars that associate with that frequency within the boundaries there, and then also I think that's it. I really like what it says here. This example go into detail about the construction of histogram using continuous data and how to create a histogram using discrete. And basically that's what I meant up there when I mentioned that, according to this thing here, that discrete usually is with ungrouped data and continuous is with group data. So I'll explain as I go through the different examples what I mean the difference between grouped and ungrouped. So this is just an introduction to this concept of making histograms. The next 2 or so examples I'm going to do is target making histogram for group data and ungrouped data. And then I'll move into other types of graphs here in this section 2.3.